This section examines tyre construction. A tyre provides a cushion between the vehicle and the road to reduce the transmission of road shocks. The air in the tyre supports the vehicle's mass, and the tread provides frictional contact with the road surface so the vehicle can manoeuvre for normal use. Radial ply tyres are usually manufactured in stages. The casing is initially formed by laying the rubber inner liner and the first layer of textile ply cords around a flat drum mould. The rubber-covered bead wire and sidewalls are then locked into position. The rubber sidewalls protect a finished tyre from curb damage and weathering. At the second stage building machine, the tyre is shaped. Belts of steel wire are guided into place. The tread is then positioned, and the uncured tyre is consolidated by rollers before it is placed in the mould. During the moulding and curing stage, the tyre is subjected to high temperature and pressure, and it takes on its final fixed identity with its own distinctive tread pattern. It is then trimmed and checked for balance and quality before it is inflated and run under load against a rotating drum. This is a final check for ride uniformity. Two types of tyre construction are common: cross-ply and radial ply. The cross-ply tyre is the older form. It is also called a bias ply or conventional tyre. It is constructed of two or more plies or layers of textile casing cords positioned diagonally from bead to bead. The rubber-encased cords run at an angle of between 30 and 38 degrees to the center line, with each cord wrapped around the beads. A latticed criss-crossed structure is formed, with alternate layers crossing over each other and laid with the cord angles in opposite directions. This provides a strong, stable casing with relatively stiff sidewalls. However, during cornering, stiff sidewalls can distort the tread and partially lift it off the road surface, and that reduces the friction between the road and the tyre. Stiff sidewalls can also make a tyre run at a high temperature. This is because as the tyre rotates, the cords and the plies flex over each other, causing friction and heat. And a tyre that overheats can wear prematurely. Radial ply tyres have much more flexible sidewalls due to their construction. They use two or more layers of casing plies, with the cord loops running radially from bead to bead. The sidewalls are more flexible because the casing cords do not cross over each other. However, a belt of two or more bracing layers must be placed under the tread. The cords of the bracing layers may be of fabric or of steel and are placed at 12 to 15 degrees to the circumference line. This forms triangles where the belt cords cross over the radial cords. The stiff bracing layer links the cord loops together to give fore and aft stability when accelerating or braking, and it prevents any movement of the cords during cornering. The cord plies flex and deform only in the area above the road contact patch. There are no heavy plies to distort, and flexing of the thin casing generates little heat, which is easily dispersed. A radial ply tyre runs cooler than a comparable cross-ply tyre, and this increases tread life. Also, a radial tyre has less rolling resistance as it moves over the road surface. The sidewalls of radial ply tyres bulge where the tyre meets the road, making it difficult to estimate inflation pressure visually. It needs to be checked with an accurate tyre gauge. Using correct inflation pressures extends tyre life and is vital for safety. Sidewalls of an underinflated tyre flex too far, which pushes the centre section of the tread up and away from the road surface. This causes wear at the shoulders of the tyre. In an overinflated tyre, the sidewalls are straightened, which pulls the edges of the tread away from the road and causes wear at the centre of the tread. A tube-type tyre uses an inner tube which provides an airtight container inside the tyre. A tubeless tyre is lined with a soft rubber layer to form an airtight seal. This inner liner also seals against small penetrations, letting air escape only relatively slowly. When a tubeless tyre is fitted, an airtight valve assembly is used. It can be a tight fit into the rim or be held with a nut and sealing washers. A tyre and wheel assembly must be balanced. As the wheel rotates, centrifugal force acts outwards. Any part heavier than the rest will vibrate vertically, with the heavy area slapping the road surface with each turn of the wheel. This is called static unbalance. Dynamic unbalance causes the wheel assembly to turn inwards and then outwards with each half revolution. As speed rises, rapid side movement of the front wheels causes a sideways vibration or wheel wobble effect at the front of the vehicle. These conditions must be corrected to prevent cupping or dishing of the tread and reduced tread life. Tread life can also be reduced by incorrect wheel alignment. The feathered edge of this tyre indicates an incorrect toe setting. And wear on the one shoulder of this tyre could be due to incorrect camber setting. Most passenger car tyres have tread wear indicators moulded into the tread pattern. They generally provide an indication when the depth of a tyre groove falls to 1.5 millimeters. Control of a vehicle in any weather conditions depends finally on frictional forces generated between the tyres and the road surface. On a dry road, a smooth rubber surface can provide a high coefficient of friction, sufficient to maintain a degree of control during braking, accelerating, and cornering. In wet conditions, the coefficient of friction between a smooth tyre and the road surface falls to an extremely low value. Grooves in the tread pattern clear water away from the contact patch area. This allows a relatively dry area to be formed and for road adhesion to be maintained. During cornering, centrifugal force acts on a vehicle to produce a side force. This side force must be resisted by the interaction of the tyre on the road surface. The greater the side force, the greater the opposing force must be. Without this resistance, the vehicle will continue in a straight line. The pneumatic tyre provides this opposing force by being able to distort while still gripping the road. Then, since the tyre's construction makes it elastic, it exerts a force called cornering force, which acts between the tread and the road surface. It pulls the distorted rubber back to its normal position. The tyre's sideways distortion makes the vehicle follow a path at an angle to the direction the road wheel is pointing. This is called the slip angle. As cornering force increases, so does slip angle. This vehicle is being driven into a turn with decreasing radius. Both slip angle and cornering force increase until a point is reached where the tyre slides, and the only resistance comes from sliding friction across the road surface. The tyre grips again only when the vehicle has slowed or is making a turn with a larger radius. That is, when the side force is reduced to a level the tyre can withstand without skidding. Since both front and rear tyres develop a slip angle in a turn, the vehicle's path is determined by the steering of the front tyres, and the slip angles of both the front and rear tyres. These slip angles depend on the location of the major components. The centre of gravity is the balance point of the entire vehicle. Its actual position depends on location of the major components. It is always located above the road surface and between the tyres. When a vehicle is cornering, this is the point through which all centrifugal force is assumed to act. Its position is determined by the load carried by the front and rear wheels. That is, by how weight is distributed. This is a 40%, 60% fore and aft weight distribution. 40% of the weight is carried on the front wheels, 60% on the rear, and the centre of gravity is closer to the rear than the front. A weight distribution of 60-40 has the centre of gravity closer to the front than the rear. Lateral weight distribution can be expressed in the same way. The height of the centre of gravity is determined by the height of the mass above the road surface. Every vehicle has static weight distribution, whether it is at rest or travelling in a straight line at a steady speed. This is changed laterally by centrifugal force when the vehicle is turning, and in a fore and aft direction during acceleration or braking. During cornering, centrifugal force puts more weight on the outside wheels. Acceleration puts more weight on the rear wheels. Deceleration or braking has the opposite effect. In a turn, centrifugal force tries to push the vehicle away from the corner. This is resisted by the cornering force of the tyres. The tyres have slip angles due to the cornering forces acting on them. And since the cornering forces at front and rear may not be equal, the slip angles at front and rear can be different too. With the centre of gravity closer to the rear tyres carry more of the weight, so they operate at a greater slip angle than the front tyres. Larger side forces act on the rear tyres, which causes greater tyre distortion. This condition of higher slip angles at the rear causes oversteer. More weight on the front tyres means they corner with greater slip angles than the rear. The vehicle is then said to understeer. With equal slip angles at front and rear, the vehicle is said to have neutral steer. Radial ply tyres generate much higher cornering forces than cross ply tyres, which is why the two tyre types should not be used on the one vehicle. Slip is also influenced by inflation pressures, so manufacturer recommendations should always be followed. This section examines tyre materials. Modern tyres are made from a range of materials. The rubber is mostly synthetic, with carbon black added to increase strength and toughness. When used in the tread, this combination gives a long life. Natural rubber is weaker than the synthetic version. It's used mainly in sidewalls. The pliers are made from cords of fabric coated with rubber. Early tyres used cords of cotton, but with increased vehicle speeds and loads, rayon and nylon cords are now common. Cords of synthetic fabric have high tensile strength. They resist stretching, but are flexible under load. The cords are placed in parallel and impregnated with rubber to form sheets called plies. Plies have high strength in one direction and are flexible in other directions. When cotton was used as a cord, the number of plies or layers in a tyre was a measure of the tyre's strength. Newer cord materials use fewer plies. A modern steel-belted radial with a 6-ply rating may have just 2 plies in its sidewall. Having fewer plies makes the tyre more flexible. Higher numbers of plies make a tyre's response to bumps harsher. The bead of the tyre is made of a cord of high tensile steel coated with rubber. The end of the ply is wrapped around the bead, which is then wrapped in rubber to stop chafing of the plies and also to seal the bead against the rim. The length of the wire used for the bead determines the rim diameter of the tyre. Belts that reinforce the tread area of the tyre are mostly made of braided high tensile steel wire, but they can also be made of rayon or polyester. The inner liner of a tubeless tyre is made of soft rubber. The inner liner must be flexible and airtight. This section examines tyre sizes and designations. The size of a tyre must satisfy some basic conditions. The bead diameter must suit the wheel rim diameter. Section width must be suitable for use on the wheel rim and large enough to have a suitable load carrying capacity for the vehicle. The overall tyre size must allow sufficient clearance between the tyre and the vehicle frame. All manufacturers mould information about the tyre into its sidewall. In cross-ply tyres, the bead diameter and the section width are stated in inches. For example, 600 by 16 indicates a tyre with a section width of 6 inches and a bead diameter suitable for fitting to a rim which is 16 inches in diameter across the bead seats. The load capacity is indicated by the ply rating, for example 6 PR. The aspect ratio of a tyre is the ratio of its height to its width. It is usually given as a percentage. The lower a tyre's aspect ratio, the wider the tyre is in relation to its height. An aspect ratio of 98% means the section height of the tyre is slightly less than the section width. This is called a cushion or balloon tyre. An aspect ratio of 88% means the height is 12% less than the width, giving a lower profile. It is called a medium-low profile tyre. The profile of cross-ply tyres was reduced further to between 78 and 82%, called a super low section. However, the stiffness of cross-ply tyres makes them unsuitable for further reduction in profile. Radial ply tyres have been manufactured in 78% profile, but are also made with further reductions in profile from 75% to 45%.